Bonjour à tous, marhaba bikoum, mon nom est Sofiane, très heureux d'être parmi vous aujourd'hui. Donc c'est le premier webinaire purement technique là, de l'association EMF. La dernière fois, donné un Q&A pour répondre à vos questions. Donc aujourd'hui, on a la chance d'avoir des invités très très intéressants pour vous parler d'un sujet qui est tout autant. Donc je voudrais d'abord profiter de l'occasion pour féliciter les gens qui ont eu leur bac cette année. Mabrouk alaikum. On vous souhaite bon courage pour votre cursus universitaire. Et bon courage à ceux aussi qui vont le tenter l'année prochaine, Inch'Allah. Et aujourd'hui, j'aurai la chance aussi d'être pas seul. Donc, on aura plusieurs présentateurs, animateurs avec moi. Donc, la première que je voudrais vous présenter, c'est Yasmine. Donc, bonjour Yasmine. Yasmine, c'est une bioinformaticienne à l'université McGill. Si tu peux dire quelques mots, Yasmine.
Oui, bonjour à tous. Alors, Kushim Murdoch pour les gens qui ont eu le bac. Alors, je suis bioinformaticienne à Universite Health Center et communication et marketing manager à Artificial Intelligence and Mission. Donc, je suis très heureuse d'être ici pour le premier webinaire de Edge AI. Et Inch'Allah, تستفادوا معنا في هذا الويبينار.
Inch'Allah, merci beaucoup, Yasmine. Je vais aussi vous présenter un autre collègue, Oussama Mahbabik.
السلام عليكم شكرا حسين مرحبا بكم معكم أسامة مراني ingénieur تاع ليزي واتسمار et actuellement analytics solution manager at Signer Trades. ان شاء الله اليوم نريبونديو لكاع لي كيسيون تاعكم وتستفادوا منها كامل.
Inch'Allah. Marhaba bik, Oussama. Donc tout ça c'est pour aussi rappeler que le concours est présent maintenant. Vous pouvez voir sur le site web, il y a la possibilité d'envoyer une application dans le cas où vous êtes intéressé par le projet. C'est toujours ouvert. Il y a de plus amples informations directement sur le site web avec les gens qui sont impliqués et aussi le matériel qui va être fourni, Inch'Allah. Donc maintenant, passons au concret, disons. On va vous présenter un peu nos panélistes aujourd'hui qui sont présents et qui vont nous parler du Edge AI. Ça va être le sujet de la présentation d'aujourd'hui, Inch'Allah. Donc, I will start with Dr. Sofiane that I will show you guys first. Marhaba bik, Sofiane. So, Dr. Sofiane, he's a lead architect at the Edge AI, at the Intel Edge AI, on the Intel Edge AI platform, sorry. Prior to that, he also received his engineering and master degree from Easy Algiers, and he also has a PhD from the Nara Institute of Science and Technology in Japan. Marhaba bik, Sofiane.
Marhaba bikum. Merci.
Now let's move to Abdenour Hadid. Marhaba bik, Abdenour. Thank you for being with us today. So Abdenour is also a PhD, so I should say Dr. Hadid. Received his PhD in electrical and information engineering from the University of Oulu in Finland. So he's also now a professor at the Chair of Excellence at the University in Valenciennes, en France. And his research interests are numerous. So computer vision, deep learning, artificial intelligence, IoT, and also healthcare. So welcome, Dr. Hadid with us.
Assalamu alaikum, Monsieur Lawan. Thank you.
Of course. Now let's move to our friend from Australia. So Dr. Hamid Laga, marhaba bik. Thanks a lot for being with us today. So Dr. Laga is an associate professor at the University of Murdoch in Australia. He received a PhD from the Tokyo Institute of Technology in computer science. And his research interests are also numerous. So we have machine learning, computer vision, and also computer graphics. And now, last but not least, thank you, Dr. Laga. Dr. Abdelaziz Khiat, he received his PhD from the Nara Institute of Science and Technology in 2007 in Japan, so just like Dr. Yus. And he is also now a senior researcher at the Nissan Motors. And his research interest includes human-machine interaction, computer vision, and also robotics. So maintenant que j'ai présenté un peu tout le monde, that I've presented everyone, what I will do is give the hand to Sofiane. You will be able to start presenting your slides. You should be able to have access to them this way. So you have the lead now.
Okay, thank you very much. Thank you. It has been a pleasure, and I think everyone here shared the excitement that I have talking to our concitoyens algériens. C'est toujours spécial باش نهضر مع les Algériens. C'est différent. كاينه حاجه اللي بالك نعاود نزيد نسيستي عليها، اللي هي بالك ما قلتهاش. هضرت عليا انا باللي كملت الانجينيور تاعي والماجستير اون الجيري، ما قلتش لا ميم شوز بور لي زوتر. اي اون فيت نوتر بوين كومان سي كو حنايا ربعه خرجنا من لجي بكري كانوا يسموها ليني بواتسمار 1997. دونك خرجنا في عام واحد ورحنا درنا سي دي تي، درنا بي اف في سي دي تي كيف عجب لي ربي. انا درت انا وحميد درنا ارتيفيشال انتيليجنس، وعزيز وحديد يقدروا يكونفيرميو درتو واقيلا عند ويكيني جو بونس روبوتيك. Donc c'est ça. Donc juste pour dire que nous sommes un pur produit algérien. And we are proud of that. I'm very proud of that. Inshallah, nous sommes là pour we understand what we have good experience that we want to share with you, and you can take the positive part of it and avoid our mistakes if we have any. So if you want to add anything, guys, Aziz, Hamid, Aziz, no? Perfect. Okay, let's get started. So AGI. I think the next, I will start with the next slide, which is the overview. Basically, what I'm going to go through is first is to understand or to try to explain why AI, why do we need artificial intelligence nowadays, and then I'll try to touch a little bit at very high level on data-driven knowledge acquisition and يعني طريقة استخراج المعلومات من المعاني من المعلومات والمعرفة من المعلومات. then نروح نتكلم على ال AGI وهو الموضوع الأساسي. ثم من بعد ذاك نهضر شوية على what is special about AI application compared to normal AI application or conventional AI application. نتكلموا ثاني كثير على sample applications. نحاولوا نتكلموا على الحوايج اللي يعني عندنا experience فيهم. We share that experience with you guys. And we finish with concluding remarks. أكتشوف نخلط يعني English Arabic. I try to make it as clear as possible. Okay, so why AI? So we are witnessing an explosion of a digital universe. So nobody can deny this. So and that explosion is causing an explosion in the data itself. So basically, we are overwhelmed with data. So even the unit of measuring the data is changing. Starting, in the olden days, we're talking about kilobyte and megabyte and gigabyte and terabyte and petabyte, exabyte and now zettabyte. So and we never know what will be next. And so what this explosion is causing, actually, it's causing first thing is amount of data that we need to do. So that will bring complexity in how to handle the data themselves, manage the data in an efficient way. But also what will bring up also is the complexity. It's increasing the complexity of the data. For example, you take a phone 10 years ago, it used to have few modalities like camera, or now you have, and then you have GPS, IMU, you have many multimodal sensors that were added. And what this adding is let's say, technically speaking, it's adding dimensionalities to the models or to the patterns we want to extract from those informations. And that's what is making it very difficult for us to translate this data into or extract knowledge from this data in an efficient way. So and that's where AI comes to the picture. Let me give you some examples and real examples. So and this is like first one, like this explosion of the data made us look very small in this world, to the level where, just as an example, that more than 99% of the CCTV video have never been seen. So nobody seen them because you cannot afford to hire as much people as you have cameras. It's impossible. So there is no scalable way of dealing with the proliferation of the amount of data. So that's increasing. So it just like it show us the explosion of the data showed us weakness. It exposed us. and that's exactly the reality. So the human is not capable of understanding the data. It cannot even handle even viewing the data themselves before even going to the next step, which is understanding the data. So as an example, the London bombing in 7th of July in 2005, I think, they hired more thousands of operators, and that's just to survey 80,000 of CCTV cameras. So those operators are not doing investigation; they are just extracting something that can be investigated, something useful to be investigated. There are different investigators that get into the picture to try to extract some meaningful information to be used for prosecution and so on. So that's and the second one, which I personally worked on, which is the London riot 2011. So أحداث الشغب في 2011 في لندن. هنا they hired 8,000 of operators to review 200K of hours of videos. And what those guys, and I had the chance to have those data from Scotland Yard, and basically, and we visited them. So we're working on a camera project with them. And so they have 20 super recognizers. They call them super recognizers. They have exceptional capability of recognizing people. And so they have all those 8,000 of people. They are there to just review the hundreds of thousands of hours of videos and extracting some suspects, so that the recognizers and the investigators get there and try to build cases and prosecute the riot causer, or the riot causing people. So what does it mean here? It means that we are enabled to. So let's take one case. For example, if it means that we are not able to be proactive, but we just can be reactive. What does it mean? It means that because I cannot monitor continuously the camera streams, I can only react to something that happens. Like, for example, bombing, something happened, they hired these people, they go through the data, extract meaningful information, trying to do investigation. But can they be proactive in that sense? They can't. They cannot keep hiring all these people working all the time just for that. And then they cannot scale to, if they increase the number of cameras. What does it mean? It means it is important to increase our sensing capabilities of the world, or our eyes of the world. But it is more urgent to actually deploy a scalable method of processing the data. And that's where AI comes to the picture. So AI is there to bridge one of the major gaps for us to deal with the proliferation or the explosion of the data. So I always give this example, and I was actually involved working with the Scotland Yard, and we have one case. It was a girl. Her name was Alice, and she was 14 years old. She was reported missing, and she took 5 weeks to get her. And this case was mostly solved with CCTV, but it took 5 weeks. And unfortunately, she was found dead, and her kidnappers also committed suicide. But it took 5 weeks. And then the question, I always ask the same question. Suppose that we have double the number of cameras that were deployed in those areas. What would be the consequence? And the consequence would be that it will take maybe 10 weeks to get to that result, because at the end of the day, we need to survey more data and so on and so forth. So that's what scalability comes to the play, and that shows how bad are we, and how urgent, how badly we are in need for this technology, AI technology, to strengthen our capability of handling these situations. So in order to get to the AI, we have to understand where we are and what are the approaches to extract meaningful information and translate the data into knowledge. And that's يعني الإنسان في عبر العصور كان يعني يبحث عن معلومات. يعني we are always trying to learn more and more, and so knowledge extraction has been always the target of human being. And but the way has changed over time. So starting from experiment to analytics to simulations, and now we are in data-driven science. Why? Because we are overwhelmed with data, and because the numerical simulation we cannot handle the dimensionality of our data, and we cannot model by hand our complex phenomena, and so on and so forth. So, and one of the major methods that exists nowadays is machine learning. Machine learning is not a new method, but it's a way to extract, as I said, to translate or to extract patterns from data. So, what is machine learning? It's building models out of data. So it learns feature model from data rather than handcrafting them. So I think it's somehow it shows that it's a recognition that we are unable to model the data by hand. So we give the data to the machine and ask them to build the model for us. So that's so why? Because we are in an era of data-driven science, and the other three options to extract the knowledge fail, and they are not useful anymore. So when do we use machine learning? It's when we are seeking to extract knowledge, when the existence of pattern, when the pattern exists in the data. So if I have hundreds of images and there is absolutely no correspondence between all of them, the only thing I will learn is that there is nothing. There is no pattern. That's the only information. So the pattern has to exist in the data. The pattern cannot be modeled mathematically because it would be stupid to extract or to try to build a model for something that we can model by hand. And the data are largely available. We have to have enough data to model the system, and here we have those overfitting and underfitting issues that can handle if you don't have enough data. So deep neural networks are an example of maybe the most recent machine learning techniques, and they are not recent because they started early in the last century, and so they were developed with the backpropagation information in the 80s. But then there was a slowdown in the development of this approach because of the compute requirements. So soon they found that they cannot go any further if they don't increase the depth of these networks. And then they found out that actually the compute capabilities at the time were not enough. So they were slowed down. And then the resurrection happened in 2000s after the introduction of the GPUs. So now we are in the DNN journey. So everything is DNN based. So it's what the recent DNN show that they can, in some occasions, they can even exceed the human capability of recognition. They are mostly optimized for GPU. This is because they were resurrected because of the GPU. So they are mostly optimized for GPU. I think this works somehow against. I will show later, that this is maybe a weakness or a negative thing for Edge AI, especially for the most advanced Edge AI and accelerator and NL accelerators. So they are mostly handcrafted, but there are techniques like network architecture search, NAS, and other techniques. But mostly it's a human come up with a topology. And use data to train, and here are some examples, like the first DNN LeNet5 for digit recognition, and then recurrent neural networks to capture the dynamism aspect, and GoogleNet, one of the most famous networks for classification. Okay, so now we answered somehow the question for why AI, but now it's why Edge AI. So let's review the data life cycle. What can we do with what are the steps of translating a data from the time it is captured to the time it is mapped to some semantics or knowledge. So first step is gathering. So we get the data. Then farming. Farming means it's a representation. It's translating them into something that we can manipulate. Kind of description, the dimensional reduction, indexing, and so on. So then come mining. Mining is kind of trying to extract patterns without mapping those patterns into some sense or some meaning. And the last step is translating those patterns into some meanings, and that means apply projection into the science or to the knowledge base or to semantic mapping. Okay. Now, what we have now, I mean, there are a lot of development in terms of frameworks, in terms of method to deal with every single cycle or every single step in the data life cycle that I presented. We have, but the reality is that we are still not able to cope with the growth of the data. So and why? Because most of these data, they are not applied at the time where, for example, the farming is not applied at the time the data are grabbed, but actually everything is centralized, or most of the times, So we cannot afford to wait until the data become big and then we cannot deal with them. So the idea here is that we have to deal with the full data cycle. What does it mean? It means I have to be able to fit the processing as early as possible. So, for example, if think about it, I have a building, and this building has hundreds of cameras, okay? And this building is in a city, okay? So I have hundreds of cameras. So my purpose is to track people, okay? So I don't need to wait to transmit all, because detection is local, something that you can apply at the camera. Okay. What you cannot, you can detect people at camera level. What you cannot get is, for example, re-identification and identify the same person in two cameras. And here you need to go to a different place, which is the gateway, for example, where you have access to multiple cameras. And then to track the trajectory of people, you cannot do it at single camera or at gateway. You have to go to the building level. But now, if you want to go a step further, is to understand, for example, city level analytics, then you have to go, for example, to the cloud and so on. So what does it mean is that you have at every single stage, you can fit some processing. So you have to fit the processing as early as possible, or whenever the data are ready for that processing, we have to process it. And that's the way we make our processing or our platform accessible. So this is the first motivation of AGI. I will now call Hamid to tell us why he thinks we need AGI.
Okay, thank you, Sofiane. Assalamu alaikum, Zulflawan. Just to remind the audience, if you've got any questions, please type them in the chat. Thank you. So first, thank you for the organizers of this webinar. It's really a pleasure to be here. So just to continue on what Sofiane has mentioned is probably one of some of the key factors that are really behind the success of deep learning, AI, and machine learning that we see now is the availability of large data sets, which you can use to train your neural networks. But also you've got the computation power that is currently becoming accessible to many people. For example, if you want to train a network, you can always have more or less a cheap GPU. You can put in multiple GPUs together and you can create your own high-performance machine at home if you want. But actually, there are many industries that cannot afford such a luxury. It's not because they can't pay for it, but it's because the environment in which they operate. For example, if you think about agriculture, where farmers usually they monitor their farms using drones or even UAVs or even satellites nowadays. Usually they capture a lot of data, but the environment in which they operate, they cannot, for example, to power a high-performance computer, you really need to have access to electricity. So the farms, for example, in Australia, they are usually located in very remote areas. And even when the electricity is available, usually it's expensive. Of course, you can always rely on batteries, but drones like these, they cannot carry heavy stuff. Usually, they just have the capability to carry the camera or few cameras, as well as the few like light computer to do the onboard analysis. So and also the data that is being generated requires a lot of storage, and of course you need energy to power the computers and the GPUs. It's the same case for mining industries, for example, in Algeria, but also in Australia, where the plants, the oil or gas and mining plants are usually in remote areas. If you want to have cameras or drones or UAVs that monitor the safety of the site and also collect the data and do the analysis, you can, yes, you cannot attach to them high-performance computers. And next slide, please. Can you move to the next slide, please? Yeah. Yeah. So previous one, thank you. And one solution, of course, is when you capture the data, you can always stream them into a cloud and do the analysis on the cloud, and then basically the results, you can send the results back to the site where you want to take actions or make decisions. But this solution, actually, it is being used in many applications, but in areas such as agriculture or mining, sending that large volume of data over the network is usually expensive, because you need to pay price for that connectivity for all the traffic that's happening on the network. And remote areas also, they don't have a lot of coverage. I mean, the coverage in the remote areas is not the same as what we see in big cities. For example, in mining site like this one, basically there is no or little network coverage or connectivity. And a more important problem is sometimes or often you need to make very critical decisions on the spot. You cannot afford waiting a second or a minute to trigger an alarm, or even send firefighters to a place where if there's an emergency, for example, in a plant like this one. So basically, you cannot afford delays or network failures. And here comes basically Edge AI. So instead of sending all the data that you capture into a cloud that makes a decision for you, what you can do is that you need to have a part that analyzes data on the spot and makes decisions. And part of the data can be streamed and sent to the cloud for different types of processing and analysis. So next slide, please. And this Abdenour, please, it's your turn.
Oh, sorry.
Thank you, Hamid. Thank you, Sofiane, for the inspiring presentations, and thanks for the team also for organizing this event. And thanks also for the followers. As Hamid said, so if you have any questions, so please write them down, and we will be happy to discuss them at the end of the presentation. So I would like now to share with you my thoughts regarding artificial intelligence at the edge and also privacy. So if some PhD students right now here is hearing us talking about edge artificial intelligence, why people now are struggling with big data, with deep learning, and if we ask our students to do deep learning, they will probably say that we need many GPUs, we have a lot of data, we have deep learning, and now we are asking them now that they can do the experiments or the learning on their phones or locally. So maybe some of us will feel a bit confused, right? So basically what I want to say is that more and more people now think that the deep learning or the big data can only be done on the cloud. But actually many applications can be best done on the edge, and some of the applications that Aziz will talk about later is self-driving cars, wearable, that I will explain later. So actually in some application we have no choice than doing the working on the edge. And my presentation now here, what I would like to talk about is the privacy. So one good thing when working with the age is that we preserve the privacy. Why preserving the privacy is very important? Because if we want to develop some technology, and if we do not keep into account, or if we don't take into account the privacy, so if we will lose the trust of the user, and if the user doesn't have the trust in technology, so technology will be not useful. So it's very, very important that the user will be happy and will be confident. The second point, if you are doing research, people will talk about, yeah, you should do some work and you should keep the privacy. At the same time, they will ask you also to do open research, or reproducible research, to allow other people to see your data, your algorithm. So maybe some of you will think that there is some kind of contradiction there, right? So in one hand, people ask you to keep privacy, and at the second hand, the other people also ask you to make your data open, reproducible, and so on. Basically, we can look at these 2 points as complementary, not contradictory. I explain. So if you make your data open, so people will be more confident, will like more technology, and probably you will pay more attention to the privacy. Can you go to the next slide, Sofiane, please? Yeah, so nowadays, more and more people are working on new artificial intelligence methods that preserves the privacy of people. And most of us knows more about the cryptography, encryption, and there is one of the methods that we call federated learning. We can discuss about that later. There's also some this homomorphic encryption. And in all this method, the idea is that we encrypt the data before we send it. So one good thing about the age artificial intelligence is that we avoid many of this privacy problem because we are handling data locally. So this is very, very good point of the age artificial intelligence, at least in terms of a privacy perspective. Next slide, please. I think.
Okay, Assalamu alaikum. So this is my turn. I'd like to talk about an application that I have been involved with. So at this point, I would want to explain about the need for edge AI when local decision is involved. So let us consider the case of the application of autonomous driving. In this figure, as you can see, on the left side, there are sensors which provide a lot of data about the surrounding environment of the vehicle. And at some point in time, the action planner here, as you can see, would have to take a decision based on what it sees, and then it decides whether the car needs to stop, move, or turn, and so on. So the action planner can do this on its own. It can also rely on a much better, high-performance planner which exists on the cloud. As you can see here, if we take the second part, then the amount of data that needs to be sent to the cloud is quite big actually, and is substantial. And it doesn't make actually sense to do this in order to take a decision which is local. So the communication cost is quite high. So this is just to explain a little bit about what needs to be done at the autonomous driving level. So there is a data flow problem. Can you go to the next slide, please? So one more aspect is that usually when local decisions are needed is when we have applications that are time critical. And you can see in this video an example of that application. So when you design an application that is time critical, usually you would like to optimize your system such that you will minimize as much as possible any unwanted situations. And if we stick to the approach that we rely on the cloud in making decisions, then we are actually opening up ourselves to so many problems that whether we like it or not, intentionally or unintentionally might occur. So it's really not wise to do that kind of approach in applications similar to this one. And I hope I was able to argue the importance of Edge AI for this kind of applications. Now I give the floor to Sofiane again.
Okay, thank you very much, guys. I think it was very convincing that Edge AI is important. So I will now touch into what is special about Edge AI. So if as a designer, if you are designing application, what are the aspects that will make your application more or a fit for Edge AI? So before then, we have to understand why we don't have why Edge AI is different. I mean, what is the biggest difference that we have to take into account? And in fact, it is the resource constraint, because when you are on the edge, you have limited resources. These resources can be memory, can be compute power, but also and power. Compute power, memory, and the power. Okay. So, for example, when we try to create what we call key performance indicators for applications, for AI application or for inference applications, if you are in data center world, you will be talking about performance per watt. يعني تشوف شحال تريتي من ايماج بار سكوند في الثانيه الواحده. ولكن عندما تكون في الادج تولي تفكر كاين يدخلوا بارامتر اخرين اللي هما شحال من ايماج، شحال من انفيرنس اللي نقولوا الايماج دير لها معالجه في الثانيه في الوات. يعني هنا عندك تاخذ more constraint into consideration. So if we just try to visit what are the steps in building, or we are talking about DNN here, is how to bring a topology to deploy it on edge. So first thing to do is for user to design a topology. And this topology initially doesn't have any colors here, means the weights are not trained. So you need some data to train the weight. And that topology is similar to the three examples that I have shown so far, like classification or detection network. So you end up with an application with the trained network. This trained network goes through what we call system compiler. You can, many people call it different names, but basically it is translation of this topology into an executable form, and this executable form will be deployed for inference and during the application. Okay, so this is for AI, regardless of whether be it edge or the data center or anything. Okay, so once this is projected in the Edge AI world, then there are many stuff that we can do. Okay, first one is here. What we can do here, we can design a topology which is resource constraint. What usually we refer to this as hardware-aware design. So what does it mean is that I cannot take a network, for example, ResNet 50, which was trained, or GoogleNet, trained to discriminate 1,000 objects, and I will deploy it on the edge to find people. So here, I mean, clearly you can remove a lot of complexity in your model and still achieve the same accuracy. So what does it mean? It means the network as it is for 1,000 classes, it's an overkill for that application. Okay, so just I have to step back here and tell you guys, I may be going a little bit deeper than what you need even for this contest. So don't be scared for that. You may not need any of these, but the reason why I am bringing this up here, because in our rules we accept that we will have PhD people who will try to maybe think about creating or considering a project in this field. So these are maybe the hottest topic or few of the hottest topic in the area. So if you want to do something on the enablement point on side of things, these are very hot topics. So but yeah, don't be scared. So just if you don't understand anything, just forget about this. So yeah, you can do something during the design. You can train the model to take advantage of some of the features of the hardware. Here, for example, I am talking about sparsity and quantization. Like if my hardware will not process the zeros, so I can and take advantage of that, then I can do during the training, I can introduce more zeros and try to do that without lose a lot of accuracy. So the second thing, or the third step here, which is during the compiler, which is during the translation from the original form into the executable form, there are what we call hardware independent optimizations and hardware dependent optimization. These optimizations here, they have benefit, or they can get benefit to any topology, regardless, or any platform, regardless of whether it be edge or not. But the second part, which is important because it takes into consideration the features of the hardware and use that during what we call optimization steps. So basically, that's what I work on, all this thing here. And then the last step is the runtime. So when you deploy when you design an inference engine which is running, which is executing the inference at the runtime level, you try to have first a hardware which has lowest what we call overhead possible, but also design the inference engine in such a way that will avoid all of those things. So so this is basically what is special. Now, as I said, you are not going to have enough time to consider any of these, but this is just take it as a general culture for the moment. But for people who will be doing their PhDs and so on, this might be an opportunity for them to work on something which is very advanced and very high impact. That's why I brought it up here. Okay. Now we go to the last before the last step, which is applications, and I will go back to Hamid.
Okay, thank you, Sofiane. So from now on, we will talk about applications, where to use AI and where you can use AI, and where AI and Edge AI can actually help. And my little contribution is on food security mainly. So as we know, actually in many countries, food security is part of their homeland security strategy. So it's an important topic for, well, literally it has to be important for every country, including Algeria. So what we know actually is that we have limited land, so the land is not growing over time. In fact, actually, it's decreasing. The land is decreasing because of the urbanization that we see and so on. So, and also there is a climate change. For example, we know that the temperature is changing. We have more fires and more floods and so on. And all these factors actually are affecting the productivity in agriculture. So in many countries, what they try to do is how can they increase the efficiency of their agricultural industry without increasing the environment, without increasing the environmental footprint, and also without with less cost, with minimum cost possible. So, and here AI comes in play, and I will use an example where on smart fertilization of crops. For example, you've got a field of wheat, you need to plant wheat, and you have to manage the farm in a very efficient way. And when I talk about management, is how much water you're going to put into your field and how much fertilizers you're going to use, and when you have to put it, and at what time, and in which area you have to put the fertilizers and water your plants. So how do they do this? What they do is that usually they monitor the field using either drones or cameras mounted on drones or UAVs. And those UAVs, what they do is that they scan the field and you capture the data. And then once you capture the data, you analyze these images to find out the conditions of the plants, whether the plant is under stress, whether the plant needs water, whether the plant is not healthy in that case, whether you have to put in some fertilizers in that area. And then once the problem is, if you put the fertilizer in in the wrong place and at the wrong time, basically you don't get the outcome that you expect. And also it has an environmental impact because fertilizers are polluting the water sources, so they have huge damage. So from the data that is captured, what they do is that they try to predict the different growth stages of the plant, and then predict what is the best time to apply that fertilizer. And also you can use the data that has been captured during the growth season to predict what would be the yield at the end, because if you put in a fertilizer, there is a cost for the farmer, and usually it's very expensive. You need to know, for example, the production at the end of the season will be able to cover your investment, and also basically there is a return on the investment. So what AI does is to automate the data acquisition. So instead of going out there and do the measurements manually or just by looking or measuring things using a ruler, what you want to do is that you need to send a fleet of drones or even autonomous vehicles that will scan your field, and that has to be all automated with the AI. Then you've got, once you have captured the data, you need to extract from this data some features, or you need to measure some properties of the plants. And what AI does is to automate that process, and even to make it more efficient and more accurate. For example, you want to measure the height of the plant, how high it is. You need to count the number of spikes and spikelets in your field, and so on. And once you have collected all those phenotypic traits or various types of measurements, you want to do some kind of predictive analytics, where there you bring all the data, those that you have captured from images, plus the environmental data, plus the weather data, the soil data, and so on, and do some kind of predictive analytics. For example, you want to predict the yield, and this is very important. You want to predict the best harvesting time or the best time for applying fertilizers, and so on. Can you move to the next slide, please, Sofiane? Yeah, those are examples of projects on which we have been working for a while now. So we use both land-based as well as aerial platforms to scan the fields, and from there we can measure the plant height, the plant biomass, which is an indication of the yield at the end. And also we can assess the plant health for different type of images. And if you want to know more about this topic, you can always refer to these two publications. Next slide, please, Sofiane. And this is actually a typical an example where it's really easy to apply very basic machine learning or neural networks techniques to get some kind of useful information from your images. In this example, what we want to do is we want to estimate the yield of a wheat field like this one. And at certain growth season, we will be able to see the spikes. So what we use is aerial images in order to detect the spikes. I'm not sure that you can see them from these slides. And also be able to measure their length and even actually count the number of the little spikelets. And this is an indication. The farmers, they use it to estimate yield, and also you've got the insurance companies and also the governments to estimate what will be the national production at a certain period to secure food for the population, basically. So the same techniques used here are also used for livestock management. For example, you know that in New Zealand and Australia, you've got more sheep than humans. So sheep industry is very big. And what the farmers, for example, what they do is that they need to make sure when their herd goes out in the morning, they need to make sure that they come back. All of them come back in the evening. So they need to count them, to detect them and track them where they are moving, and also count them, and even actually measure their size and how do they grow over time in order to estimate what would be the quantity of meat they can get after a certain period. And for all this, they use deep learning techniques, which are actually implemented on the edge. I will stop here and give the floor back to Abdenour.
Okay, thank you, Hamid.
Actually, yeah.
Oh, Aziz, sorry for that, Aziz.
Yeah, thank you. No, all right, no problem. So let me try to move to another application, a different one, the one that I spoke about earlier already. So autonomous driving. So this is actually a very hot topic and a very, how can I say, so many car makers are trying to do to provide this capability to customers. And I will explain later on some of the benefits in a specific application. Now, in this slide, I would like to explain the basics, really the basics of software architecture for such systems. So on the very far left of this slide, you can see the sensors that detect information about the surrounding of the vehicle, right? And then from there, the first software module tries to extract some useful information. Like, for example, there is a pedestrian here. There is another car in front of me, things like that. And you will be able to detect a lot of things, but then again, you need to put them in a context. And for that, we use a map. A map will allow you to say, okay, there is a car and it is coming, it is oncoming car. That means it is coming from the opposite direction. And then you can consider it or not, things like that. At the middle, at the heart of the software, there is the decision maker. And this one tries to decide what to do next, to stop, move, turn, and so on. Of course, in making a decision, it relies on a pre-planned path that has been calculated beforehand. Then once a decision is made, the vehicle control actually generates instructions for the actuators, and then the vehicle moves. While doing this, there is somebody inside the vehicle, so you need to share some information, some useful information about what's going on to the person that is inside of the vehicle. Now, I try to highlight here in this framework what needs to be at the edge and what could actually take place or take advantage from the cloud. For example, it makes sense to update the map of the environment from the cloud because the environment is changing. There is construction here and there, and the map changes. So if this is detected by another vehicle, then it could be updated in the cloud and then used later on in the vehicle. You could do road level road planning in the cloud as well. That's also significant. That's also important. When it comes to the application, when generating information to the users inside the vehicle, you can also rely on the cloud as well and extract some useful information. So this gives you an idea about what needs to be in the cloud and what needs to be in the vehicle as edge computing or edge AI. So can you go to the next slide, please? Next slide, please. Okay. So this is an application in which I was involved. We tried to see how we can use autonomous driving cars in a context that is useful for ordinary people. So the application that we wanted to do is what is called Robo Taxi. So a person books a ride in his or her smartphone, goes to the pickup location, waits for the car to come, gets in the car, moves to destination, gets out of the car, walks, and then reaches its final goal. So this is basically the basic steps that are needed for such a system. And the whole thing, the whole spectrum of actions from the beginning to the end is covered with the cloud and applications that are related, linked to the cloud. Also in the middle, the ones in yellow are covered with the autonomous vehicle. This was an application that was deployed in the area of Minato Mirai in Yokohama, Japan, and I was involved in this development. So can you go to the next slide, please? So for this, we created several vehicles actually, and this is one of the vehicles that we created for this application. This is a Nissan Leaf. It's an electric vehicle. We wanted to give how can I say? We wanted to show the people that we can do good stuff with electrical vehicles. We don't have to rely on fossil fuel. And you can see that we put so many sensors integrated in the vehicle. So this is not a typical autonomous driving vehicle where you have a sensor on top of it, which is actually very typical in other vehicles. But for us, it's important to keep a good and beautiful design of the vehicle. So all the sensors are integrated in the body, and it makes the problem actually more difficult to solve, but it's very important from our point of view. Can you go to the next slide, please? So this is, I'm going to show you this video, which explains actually the service and how it was done, how it was performed in real world. And ordinary people were able to use this service for several weeks. We have been doing this. We have been doing these rounds of testing for several years right now, and the reaction was good. And as you can see, the person calls for the vehicle to come with its phone. I don't see the video moving. Maybe it's a problem from my side, or is it? Okay, yeah. And then there is and the vehicle is moving on its own, driving towards destination, trying to get the person to go and pick out the person. The person can see actually in his phone or her phone that where the vehicle is, whether it's gonna come to it or not. Once the vehicle reaches it, the person, you can do some simple verification to get into the vehicle, push the go button, and then you are off to your destination. So this is the whole the steps I spoke about earlier, and we were able to develop this system in collaboration with DNA, another software company, Nissan and DNA together, and it was quite interesting. If you want to see more about it, you can just follow the link below and you can get more information. Now I give the floor to Abdenour, right?
Thank you very much, Aziz. Yeah, so I would like to share also here some ideas or some work that I have been doing on the application of artificial intelligence for healthcare monitoring. Actually, if you go nowadays to any shop near you, you will find a lot of devices to monitor, including rings, watches, necklaces, even mobile phones, which tries to monitor your health information. Some of the gadgets, some of the devices are working very well. Some of them, they are just like gadgets. So nowadays, with artificial intelligence, actually, we can do better than that or more than that. Actually, if you remember before, in order to estimate your heart rate or your health information, before you have to put your finger on the flash. But nowadays, actually, many devices can work without any contact. Just by looking at your phone, the phone can estimate your heart rate and stuff like that. So this is thanks to artificial intelligence. So we are developing, or we did already develop a lot of application about healthcare, about health monitoring without any contacts. So why now we are talking about it's important to do it on the edge, because we are handling or we are processing very sensitive data. We don't want that if the phone or if I have a device, a ring, collecting my health information, I don't want that this personal or information will be shared with others. So it's very important. I would like that the information will be stored locally. I will be the only one who will see the information and who will decide if it will be shared or not. So this is the importance of the edge artificial intelligence for health monitoring, because people don't want that their health information will be shared or will be even distributed. So it's very hard to distribute data from hospital. They are very, very sensitive data. So this is one of the applications. Next slide, please. Yeah, so this is just like one of the survey paper that we did actually. So if you read this paper, it gives you a lot of information about the health information that we can get from your face and voice and so on. Let's move to the other slide, please, Sofiane. So yeah, another application also of artificial intelligence is the biometrics. So actually in the future, we are expecting that every object will be connected to internet and every object will know who is using it. For example, now I am having this pen here, and in future, the pen with my fingerprints, the pen will recognize me. And if I am happy, the pen will write in green. If I am sad, the pen will write in red, so on. So the pen will recognize the owner. So, and also it's very important also that the information about my personal information will not be shared. So this is why we need edge artificial intelligence for this kind of applications. Let's move on, Sofiane. So yeah, so now I have the pleasure to conclude what we have been talking. So we are a little bit over time. So what is the take-home message now? So I saw some of you is asking, or if you have an application, should you go for to solve it in the cloud, or are you going to solve it on the edge? So basically the answer is that it depends. So in some applications we have to work, it's much better to work on the edge, especially for the autonomous driving. For autonomous driving, we cannot wait, we cannot send the information and wait for the answer from the cloud to take a decision. So it's very important. So in some application, it's very important to go and try an edge solution. Another example also is the healthcare problem. So it's very sensitive data, so we cannot share that. So it's very, very important to consider an edge solution. In some other application, for example, weather forecasting, so for that maybe we can consider a cloud solution. For the agriculture, maybe this is my question to Hamid later on. I don't know if we should consider an edge solution or a cloud solution. Maybe Hamid later on will explain that. So the second point that I would like to raise here is that in some applications, as Sofiane said, in some complex application, we can combine an edge and a cloud solution. For example, in the edge, we can do encryption, we can extract the features, then we send features and stuff like that. So we can combine them. The third message that I would like to highlight here is that nowadays, artificial intelligence is everywhere. And also, we have a lot of edge artificial intelligence platform. So it's accessible to everyone. And thank you very much. So I will give the floor to Sofiane, Yasmin, and Osama. Thank you very much.
Thank you so much, Abdenour.
Sorry, it will be back to Hussein and Yasmin and Osama. Thank you, guys. Thank you, guys.
Yeah. Thank you so much, guys. Let me just change the view.
Can I just say something before you go? On est vraiment désolé. يعني كيف يقولوا we are very sorry. حبينا نديروا عربية الآخر مي باش تكونترولي الوقت وسي بروميير فوا يعني باش تهضر عربية سيتي ديفيسيل دونك سمحوا لنا بزاف دونك وإذا يعني we can answer your questions اليوم وإذا ما عندكم دي كاستيون ما تقدروش يعني ما كاش الوقت زين please reach out to us. We will be more than happy to address anything it's not clear to you. Thank you.
Exactly. Shukran, merci beaucoup, Sofiane. Donc voilà, merci beaucoup d'abord à nos 4 présentateurs. C'était très intéressant. J'espère que les gens qui écoutaient le live ont apprécié le contenu tout comme moi. Donc comme on l'a spécifié au début, donc on va passer aux questions. Donc on a eu beaucoup de questions en fait sur Facebook. Ce que je vais faire, c'est que Nibda par ordre chronologique. Donc Nibda li pose les questions en premier. Je vais les afficher à l'écran. Et ensuite, je vais désigner quelqu'un pour répondre. Si jamais habitou demander une question à Wahed en particulier, اكتبوا اسمه. Je sais que ça a été fait dans les commentaires. اكتبوا اسمه. Et à ce moment-là, on peut directement prendre la question à lui et l'envoyer un de nos 4 présentateurs. Donc, sans plus tarder, je vais d'abord enlever la bannière qui est là. Et je vais passer aux commentaires. Donc, le premier commentaire que je voudrais présenter, je pense que ça s'adresse à Sofiane. La raison pour laquelle je pense cela, c'est parce que ça a été posé au moment où Sofiane est en train de parler. Donc, la question est la suivante. Is it possible to get... Oh, not this one. Hold on. It's the next one. C'est la même personne qui l'a posé. Je vais aller chercher la question. Voilà. My question is an issue on how to pass from theory to practice, programmation or implementation. Donc, cette question a été posée dès le début, Sofiane, lorsque tu présentais au début de ta présentation. Et d'après ce que je comprends en ce moment, il demande comment est-ce qu'on fait pour passer, disons, de l'ordinateur du développeur ou du chercheur à directement quelque chose qui est plus présentable en production et utilisé par les
donc, very difficult question. I don't think there will be a single answer for this, but I think that especially nowadays, it may be dangerous sometimes, but I think many people who consider themselves as DNN or machine learning engineers, a lot of them, they are just taking topologies and deploying them. So I think that's the easiest path to go, or this way to go from theory to practice. That's because at the end of the day, machine learning made it possible for you to take a network as a black box, and it can do all what you want. But as long as it was trained, proven somewhere else, you can take it and prove it, and deploy it. And it may work for exactly the same application, the same constraint. Maybe if it was trained exactly for the same classification. But I think when it comes to the edge, that's not less efficient, because what I was referring to is that maybe you can start with getting something to run on Edge AI, okay? But if you want to go very far or very advanced, you have to address what I was referring to as advanced topics, like, for example, how to take into consideration your hardware specifications, your constraint of the hardware, into the topologies, the design of the topology itself, on the training itself, and maybe something which will be virtual to you, which is, and that's maybe my contribution, is the compiler hardware dependent optimizations and the low overhead runtime. Now, it sounds like very difficult, but actually I think there are all the tools that will make it very, very easy for anyone to do all of this. Now, to a certain level, we are not talking about advanced optimization for specification and so on. Those are hot topics that are growing. But designing your topology, training it to do something, and deploying it, it's never been as simple as it is today. So there are all the tools. I think you can simple. You can take the frameworks like I don't know, TensorFlow. You have Caffe. You have a lot of other platforms. They can help you to design, to train, and to deploy. So the tools are there. I think, as I said, you can do what you want, but you can do it at different level of excellence. And that's, I think, you can start with getting something to work, but and then that overhead for going from theory to practice will be a bit easy. It gets more difficult when you want to go to the edge of performance, to the edge of excellence, and that's some of the topics that I mentioned today, they are still like very, very hot topics, like very new things, like hardware aware stuff. They are very, very hot topics.
Perfect. Thank you so much, Sofiane, for your answer. On va passer à une prochaine question. Voilà. Donc, je vais passer à une prochaine question. Oussama, je voudrais te donner la parole pour cela. Et c'est aussi une question qui vient du public aussi. Merci, Oussama.
So the question is ما هو الذكاء الاصطناعي هل ممكن مثالا عن الأماكن التي يتم فيها استخدام الذكاء الاصطناعي على أساس يومي وخاصة في الجزائر. En français, ça donne en quoi l'intelligence artificielle, c'est quoi, pardon, l'intelligence artificielle, et est-il possible d'avoir un exemple de l'utilisation quotidienne de l'intelligence artificielle, surtout en Algérie? And finally, in English, what's the artificial intelligence, and is it possible to have an example of AI daily use case, and especially in Algeria? For this, I will let maybe Abdenour answer the question.
I don't know if I will. Yeah, thank you very much for the question. Hussein, I don't know if I will answer in Arabic or in English or in French. So my Arabic My Arabic is not that good.
كيما
قبل
تلعب
هي
I will try to answer in French.
Azurek.
Donc, le monsieur, ou bien, ouais, il nous demande qu'est-ce qu'on peut faire avec l'intelligence artificielle en Algérie, c'est ça, non? Donc, je pense que dans nos jours, tout le monde utilise l'intelligence artificielle. Donc, elle est partout. Donc, elle est utile. Donc, elle remplace l'homme dans pas mal de fonctions, en fait. Donc, le seul problème, c'est quoi la limite de l'intelligence artificielle? Donc, on n'arrive pas à expliquer qu'est-ce qu'il y a derrière. Mais sinon, comme application, on est dans le monde de big data. Il y a beaucoup de données. Donc, l'homme n'arrive pas à traiter toutes les données comme Sofiane a dit tout à l'heure. Donc, on est vraiment dans l'ère de l'intelligence artificielle. C'est extraire, c'est basiquement, eh bien, on est en train de copier le cerveau humain, en fait. Donc, il y a pas mal d'applications comme les voitures autonomes. Et la question qui se pose, qu'est-ce que l'Algérie peut faire, par exemple, dans le domaine de l'intelligence artificielle, comme notre collègue Hamid a expliqué, par exemple, dans le domaine de l'agriculture. Donc, on peut utiliser dès maintenant déjà l'intelligence artificielle pour améliorer le domaine de l'agriculture. Et merci.
Parfait, merci beaucoup.
Hamid ou bien Sofiane peut ajouter des choses. Hein.
Oui, bien sûr, c'est une discussion qui est ouverte.
حميد جو بونس كو حميد يقدر يجاوب خير يعني خير مني ماشي خير من عبد النور.
Mais je vais ajouter peut-être dans le domaine de l'agriculture, en fait, si on regarde par exemple en Algérie la production, si on compare l'Algérie à l'Australie, en fait, en Algérie, on a beaucoup de terres fertiles. Vraiment, le climat est adéquat pour l'agriculture ensemble. L'Australie, elle a tout pour rien produire. Par exemple, il y a des terres, mais elles sont arides, il n'y a pas de pluie, il y a beaucoup de sel dans le sol ensemble. Mais l'Australie, c'est le 4e exportateur de blé au monde, de céréales au monde. L'Algérie, c'est peut-être le 1er ou le 2e importateur au monde. Donc, les Australiens, qu'est-ce qu'ils utilisent? En fait, ils utilisent la technologie, par exemple, pour l'irrigation, par exemple, est très contrôlée. Par exemple, ils utilisent, en fait, à partir des données, ils analysent les données qu'ils obtiennent. Ils arrivent à déterminer où il faut mettre de l'eau, il faut mettre des fertilizers, et so on. Et puis, il y a aussi la génétique derrière. Il n'y a pas uniquement l'intelligence artificielle, il y a la génétique derrière aussi. Donc, moi, je pense, par exemple, dans le domaine de l'agriculture, il y a pas mal en Algérie, c'est un secteur qui est vierge et l'intelligence artificielle, l'analyse de données, computer science en général, elle peut contribuer beaucoup dans ce domaine. Et puis, par exemple, c'est un domaine de Hadid aussi, c'est dans les voitures autonomes. On connaît en Algérie, par exemple, la circulation, le trafic, comment est-ce qu'il est. Donc, avec l'intelligence artificielle, ça peut résoudre pas mal de problèmes. Par exemple, les accidents, ils sont très fréquents en Algérie. La voiture autonome, elle peut réduire ces accidents, par exemple. Voilà, j'espère que j'ai répondu un petit peu. Bon,
Parfait. Oui, merci beaucoup, Dr Laga.
Je veux juste ajouter quelque chose qui était dans les concluding remarks, which is, كما قلنا, AI is accessible to everyone. I think Hamid, the application Hamid presented are proof that there are a lot to do in
je peux ajouter, par exemple, les applications que j'ai présentées, au fait, c'est les techniques de base de deep learning qu'on a utilisées. Il n'y a pas de magie à un sens.
Exactly.
C'est des techniques de base. Il suffit juste au fait de les entraîner pour le domaine spécifique et de les implémenter sur la plateforme adéquate. Et ça donne des résultats assez impressionnants, en fait.
I think what will be interesting also to try to investigate by our students is how to localize some of these ideas. Like حميد انت يعني شفنا بزاف الجرين في التصاور تاعك ياك. I don't think you will see a lot of green في الجزائر. بصح I think the intelligence behind the enabling technologies behind, they apply to whether it is a desert for detection of something else and so on. So there are a lot of reuse of technology that can be applied in Algeria with a lot of benefit, and that would be kind of low-hanging fruit, getting something that works, try to, get the data and think what to do, what can you learn from. There are a lot of stuff. I think in the process of this initiative that we are putting together, we are available to you to guide you through your applications, and also to work together, or maybe infer your thoughts about what makes sense what makes sense to develop and how to localize it, how to personalize it to the Algerian environment and Algerian reality, economically, nationally, and everywhere, and all other aspects. Thank you.
Perfect. Thank you so
Very
much.
small comment about that,
Yes.
if I can. So the minor or the problem with the Algerian mentality or whatever. Non, je vais parler en français. Donc, le problème qu'on a avec la mentalité algérienne ou bien avec les décideurs, c'est qu'en général, on achète des produits déjà finis, en fait, des produits en intelligence artificielle ou bien autre chose. On achète ou bien on penche sur des produits finis. Or que on doit faire de la confiance aux chercheurs algériens, à algériens pour qu'ils développent eux-mêmes, et ils sont très capables, des solutions basées sur l'intelligence artificielle, en fait. Au lieu d'acheter déjà des packs ou bien des solutions déjà faites ailleurs. Donc, je veux dire qu'on doit donner plus de confiance à nos étudiants, à nos chercheurs algériens.
Well, you're pushing me to say something more,
Please.
and sorry to take the bandwidth, guys. But I think this is a very, very important point, because sometimes you are touching to what is strategic to the country. Something we do it optionally, and that's fine. We do it for gain and so on. But the dangerous thing is when you do it for something which is strategic. I mean, how can I buy a smart camera and trust the intelligence in it and deploy it nationwide? I think thinking about artificial intelligence soon will become a strategic question that has to be thought of in the context of the whole country. What we must develop locally, what we can or can do. Maybe we are not going to the critical applications in this I think initiative, but I think the enablers are the same. The enablers are the same. So, but there are some fields that maybe that's beyond what we target here. But it's touching into what is strategic to the country. Thank you.
Thank you so much. Merci beaucoup, Sofiane. Je vais retirer la question. Donc, on va passer à une prochaine question. En fait, cette question, c'est moi qui va la poser. Elle vient pas de Facebook. C'est pour Dr. Khiat que je vais mettre ici. Voilà, donc en fait, au début de votre présentation, vous avez parlé de avoir transféré de large amount of data, beaucoup de données en direction du cloud, et que cela était très coûtait beaucoup d'argent et d'énergie pour faire cela, et par conséquent, vous avez décidé de déplacer la logique directement sur le véhicule, donc avoir des décisions qui sont locales à la place des envoyer sur le cloud. Je voudrais vous demander en fait, l'énergie ou le bandwidth qu'on a sauvé à la place d'envoyer directement sur le cloud, ne va-t-on pas le perdre directement sur la batterie? Est-ce qu'on va pas se retrouver avec des véhicules qui vont être moins efficaces parce que la décision se fait directement moins efficace, qui va nécessiter plus de batterie, plus d'énergie parce que la décision se fait directement sur le véhicule? Merci.
Ok, merci pour la question. En fait, c'est vrai, ce que vous venez de dire là, c'est un des problèmes en fait qu'on aura à résoudre dans ce genre de situation. Mais il se trouve que il n'y a pas there is no free lunch. Donc, quand on gagne d'un côté, on perd de l'autre côté, etc. Tous les problèmes du monde entier sont des problèmes d'optimisation. Donc, on optimise le plus qu'on peut. Plus de calcul sur la voiture, moins de batterie. Alors, quelle est la meilleure combinaison? La combinaison optimale qui va nous permettre d'être performant et ne pas perdre beaucoup d'argent ou bien beaucoup d'énergie sur le système. En fait, ça revient à cela. Donc, il n'y a pas une solution miracle, il y a une solution optimale. Bien sûr, optimal, ça veut dire qu'on perd quelque chose quelque part. Donc, je ne sais pas si j'ai répondu à la question, mais c'est à peu près comme ça. Et c'est valable dans tout domaine, dans toutes les conditions, etc.
Parfait.
Voilà.
Ok, merci beaucoup. C'est très bien répondu. Je vous remercie pour votre réponse. Je vais passer à la prochaine question que nous allons tirer directement de Facebook. Donc, je vais aller la chercher. Donnez-moi un petit instant. Et elle sera adressée plus spécifiquement à Sofiane. C'est quelqu'un qui a demandé à vous Voilà, normalement, vous devrez la voir. Donc, c'est quelqu'un qui l'a demandé directement à vous. Donc, je lis la question rapidement. Dr. Sofiane, thank you for the presentation. In one of your slides, you mentioned that HW depend optimized. Does it mean for each hardware you need to develop a single different design flow? Can we make the HW smart and learn from the previous runs to adjust code optimization at the runtime? Je vous laisse la parole. You're muted. Oh.
I am on mute. Yeah, you can do whatever. I mean, you can do that. We can definitely do that. But the problem is, can you afford to do that? So can you afford to run the compiler, the compiler at that stage? If you can do, yes, you can. This is optional. You can have but you have some applications where, for example, you can. What you are referring to here as adaptive. Can I show my slides here?
Yes,
can
of
you
course.
switch them?
Yeah.
Please. Yeah. So basically, you are talking about hardware-dependent optimizations. So what this is doing is taking it's not. It doesn't mean that it is specific. Okay. There are some generic aspect of this hardware-dependent optimization. It depends on how it has been designed. Definitely. Definitely, it takes into consideration the characteristic of specific hardware. But the question is, I mean, because what is the requirement for you to have that to delay the compiler at runtime stage? What we call, I think you're referring to what we call just-in-time compilation. Okay, so if there is a good reason, yes, you can do it. Now, you may need to do it at different iterations and go gradually to an optimized form, and that may mean that you are going to split your overhead over multiple iterations. But basically, what you need to do is to evaluate the overhead. If you are happy with that and you have enough requirement to do it, then you should do it. But if it is not necessary, it's not recommended. Why it's not recommended? Because normally the model can be compiled once and for all and deployed. If there is any reason not to do it, then yes. What you are talking about is it's a kind of adaptive compiler. It is possible, but this is very advanced question. I would love to have maybe an offline discussion with you, whoever asked this question, and give you maybe a more thorough answer. I don't think it will be the best use of the time of other audience, I think.
Perfect. Thank you so much, Sofiane. So this question was asked by Ismail Nair. Thank you, Ismail. We will jump to the next one. We have here Honoré Yassine, who asked us, first, thank you for this great webinar. You're welcome. As an embedded software engineer, I got interested in Edge AI. I can see the great opportunity applications offered by this tech for good intentions, like go to medicine environment. But unfortunately, AI will be in general used by governments, politics, and private groups, GAFA, Facebook and Google, etc., leading to a capitalism of surveillance. With Edge AI, data is handled locally, so we win in latency, privacy maybe. As we extract meaning from the unfortunately we can't see it entirely, but I would remove this one here, but I'm going to ask Dr. Laga if possible if he can answer to that. But I would assume what he's asking is how can we since data is now used by a lot of big corps or big government, how can we deal with that, since it comes most of the times, or at least some of the times, by us or by agriculture or other IoT? Thank you, Dr. Hamid.
Yeah, I'm not sure whether I can give correct answer, but I think Aziz has mentioned that there is no free lunch. Whenever you're giving your data for free, it means that you are the product. So the other companies are capitalizing on that. But I think from our side, we need to look at the opportunities that this offers, rather than just being stuck in that mindset, okay, they're going to use our data and they're going to do other things. We need to capitalize on the opportunities. For example, the 4 companies that you have mentioned, they are probably the key companies that took the deep learning into the level where we are now because of the data that they have been collecting over many years and also the computation power that they put behind. And that has actually took the neural networks into the level that we see them. So privacy is always an issue, so we need to be careful in what data that we need to put online to the clouds and what data that we need to protect and so on. So I don't have really definite answer, but I think probably my only suggestion is look at opportunities in that space.
Perfect. Thank you so much for your answer. Je vais passer à la prochaine question. Donc, cette question, je vais l'adresser à Dr. Khiat. Elle nous vient... D'abord, je remercie Yassine pour sa question précédente et je vais passer à la prochaine. Donc, voici la prochaine question. Elle nous vient de Jem. As a physicist, do you think Edge AI will replace quantum mechanics in the near future, explaining phenomena beyond the explanation of matter? This is... I'm sorry. This is for Professor Abdenour Hadid. This was targeted to him. So it's a very, I think it's a very difficult question, but I will leave you.
That's a very nice gift.
Exactly. I think now Dr. Khiat is a bit happy that yes, it wasn't for him, but I'll let you answer to Mr. Nis.
Aziz, do you want to answer? This is from my friend. He's just nearby here, you know. Nasser is just nearby. So, you know, I will go to see him in 5 minutes. So I will ask him one of his questions. So he's just nearby here. So, Aziz, do you want me to answer? Or actually, I didn't understand very well what he's asking. He's talking about this, making the age of intelligence and quantum mechanics. Yeah.
I can say something. So, well, you see, these are two different things and maybe the same. Anyway, so this is physics, right? And physics tries to see how the world works and try to model it and so on. Quantum mechanics is a field that is important in physics, and I believe that physics has been able to advance greatly in recent years. Due to the capacity of computers to do a lot of simulation, right? And basically what I try to understand from this question is the fact that physicists rely a lot on simulation, and does it make any sense to see towards edge computing in this kind of situations? I don't know actually, because I believe that physicists try to deal with big problems that need a lot of computational power. And maybe Edge AI is not meant for physics problems. That's my take on it. I might be wrong, but maybe that's my take.
Yeah, I think the last comment, the last part, maybe explaining the phenomena behind the explanation of matters. It looks like a nested intelligence, where it's similar to network of networks, that a network that design a network. So you don't have So we are going step, from given the data to the network to the machine to build a model. Now it's we give it the data to machine to build a model that makes models. So that's
perfect.
If I can add something as well, I think there are also nowadays there are two schools or thoughts. Basically, there are those who like actually understanding things and trying to explain them using physics and so on. And there is the AI community, and many people in the AI community even think it's data-driven, and the network is more or less a black box. So usually we don't know the process. It's difficult to find out the process that led from the data into the final decision. So there is this two thoughts, and usually they are competing with each other. But I think they would benefit from each other rather than being competing.
Perfect.
I will just add a few words to answer my friend here, Nasser. So for the explainability, I do believe that artificial intelligence will be useful to explain a lot of physical phenomena. But regarding whether we should use the edge artificial intelligence for the in the field, I think that I don't see the need of why we should use the edge. I don't see any privacy issue. I don't see any real-time issue. So I think that I'm not sure if the need of the edge is important here. Yeah, thank you.
Perfect. Thank you, guys. Merci beaucoup. Je vais passer à la prochaine question qui nous vient de YZ. What are the possible applications for emotional recognition in self-driving cars? So ça revient un peu à ce que Dr. Hadid et Dr. Abdelaziz Khiat a travaillé dessus,
Okay.
donc je vais passer à
I can answer this. So I myself actually worked on in the past worked on emotion recognition and driver state monitoring, actually for to be able to detect whether the driver is aware of what's going on or not, whether he's asleep, whether he is awake, whether he's angry, and so on and so forth. So yes, there are a lot of applications linked to this, and I can give you an example. There is one car that we launched like 2 or 3 years ago, which actually watches the driver when he's driving, and it has an autonomous driving feature in highways, and the driver can actually how can I say, he can or she can let the car drive itself, but the driver needs to monitor what the car is doing. So if the driver looks away, or he's not or she's not aware of what the car is doing, the system detects that automatically and asks the driver to come back again to the task of watching what the car is doing. And it's related to whether the driver is aware of what's going on or not. So it's not exactly emotions, but it's more of how the driver state is at a certain point and reacts to that. In the past, like 10 years ago, we showed a concept car in Tokyo Motor Show that actually tries to detect driver emotion and reacts to it. It was more of a test case and to see how people would react to such kind of application. It was very interesting. It generated a lot of buzz. I would use a recent word because we didn't use this kind of word at that time, but anyway, it generated a lot of discussion among people and so on, which is, I think, a possible direction in the future. We need to understand what the people are doing in the car. We need to get the car react in a certain or another way to what's going on inside the car. And there are so many applications nowadays trying to look inside the car and what's going on, not only emotions, but more like of behavior or situations or states of the people, the occupants. For example, if there is a baby and this baby was forgotten inside the car, things like that are seeing the light, and there are products that are available now in the market, and more are coming as well in the future.
Thank you so much. All right, so thank you for this answer. Now what I will do is, je vais donner la parole en fait à Yasmine, une de nos co-présentatrices. Elle a une question pour un de nos présentateurs. Donc Yasmine, je te donne la main. Est-ce que tu nous entends, Yasmine? Est-ce que...
Oui, je vous entends,
voilà,
mais
okay.
je ne vois pas la question.
Tu ne vois pas là?
Non, je ne vois pas.
D'accord, moi dans le cas où tu peux peut-être poser une question personnelle, une question que tu voulais toi-même poser à un des panélistes.
Ah oui, c'est bon. Ok, c'est une question de Oussama Herizi. Donc il dit, je travaille dans le secteur fabrication ciment. Toute la chaîne de fabrication est contrôlée par un central room. On ne peut pas voir et contrôler tous les paramètres du système. Comment on peut utiliser l'intelligence artificielle pour améliorer les performances de notre système? Donc, je ne sais pas qui veut répondre à cette question.
I think I can maybe just try. So it depends on what you want to do. It depends on what are the control point of your chain. We have to. What you need is we need to grab data. We have to understand what to model. I think we need to understand what are the sources of data and then the control point, and that will define what we can do. But I think, yeah. So I don't think we can have an answer just by looking at the question. This is my.
I can add something.
Okay, go ahead.
Vas-y.
Sorry, I can add.
Est-ce que je peux juste donner mon avis sur ça? Parce que là, le monsieur parle parce que l'intelligence artificielle, en général, elle est exactement, elle est faite pour des problèmes complexes comme celui-là qu'on n'arrive pas à modéliser mathématiquement. Donc, dans ce cas, qu'est-ce qu'on a besoin? On a besoin de beaucoup de données et beaucoup d'exemples. Et à partir des exemples-là, on peut construire un système avec l'intelligence artificielle. Donc, quand on a un système complexe, si on n'arrive pas à le modéliser comme celui-là, par exemple, donc l'intelligence artificielle, elle est exactement faite pour cela. Donc, mais on a besoin de beaucoup d'exemples, de beaucoup d'entrées et de sorties. Et avec ça, on peut faire un apprentissage et produire le système.
Oui, docteur Khiat, si vous voulez ajouter quelque chose. If you want to add something to this question.
Yes, I just wanted to say that in such systems, usually since it's controlled, the whole thing is controlled from a room, you actually get an understanding of where the performance is low in the whole process. And then in that particular part of the system, you can put some extra sensors and collect a lot of data. And then this will connect to what Abdenour just said earlier. And then you can collect a lot of data and try to see what's going on in that particular part of the system.
Thank you so much for this answer.
But I think the reality is there is a lot you can do. I mean, definitely there is something you can do, but yeah, it depends on what you can control, what the type of data you can collect, and what are the parameters and so on.
Perfect. Thank you. If anyone wants to add anything else.
Yeah, probably I can give an example of breeders in wheat industry. Donc, généralement, je ne sais pas comment dire ça en français.
Allez-y en anglais si vous voulez. In English is fine.
Okay. The breeders, they need to design grains that are efficient for specific environments and for specific applications. For example, if you want to have a grain for to make bread, it has to have some kind of protein content. If you want to make it for pasta, it has to have different protein contents and so on. So it's like a 7-year program. So in the first year, they start by planting a lot of types of grains. They play with the genetics and so on. Then they start narrowing down, and then until they will reach their target. That process is very costly. So they have a lot of parameters that they need to control. And what they do is that basically exactly what Aziz mentioned, they need to collect a lot of data. And then I think one of the audience have mentioned covariate analysis. They will look at actually the variables that are affecting which variables. So you need to look at the different parameters, which parameter is affecting which parameter. And then you can end up with a kind of a graph and find out the critical path in your graph. And in this example for breeders and farmers, is yield is the final target. So you need to have the critical path that will lead you into that your final objective, and look how to optimize that. For example, yeah, this is just an example. I hope it helps. Yeah.
Perfect. Sounds good. Thank you for all your answers. Actually, il y en a eu beaucoup. Merci beaucoup, Dr. Laga. Merci Yasmine. Est-ce que tu voudrais ajouter quelque chose peut-être ou... Non? Ok, parfait. C'est pas un problème. Parfait. Je vais passer à une prochaine question, toujours sur Facebook. Elle nous est posée. D'ailleurs, merci à la très bonne question de Oussama qui a été répondue maintenant. Donc, à une nouvelle question de Jamal. Is there any perspective to applications in business and intelligence? I think that I will encourage Algerian enterprises to start using it. Donc, c'est une très bonne question. Moi-même, je l'utilisais un peu. J'ai déjà fait du business intelligence par le passé. Donc, est-ce qu'il y a quelqu'un qui voudrait peut-être sauter sur la question ou qui a un intérêt marqué? Oui. Okay.
So I can just start. I think this is business intelligence is typical application when it comes to analytics. You know, analytics for example, building management systems and shopping malls and so on. So it is typical deployment of something that's similar that I showed earlier, where there is always something that you to build like the shop level knowledge and analytics. You need to go through detection at sensor level, which can be mostly cameras, you know, doing detection, counting, and all of that. You have to go also some kind of hierarchy of processing, like for example fusion, like re-identification, and those will be enablers to set another level of semantics, which is as I said, counting, and another level which is, for example, activity, like interest, stopping here, going there, means you can infer a lot of stuff. So I think it's just like typical. It's a very typical usage of what we have been talking about. But basically, I think what is typical to this is to what I presented in one slide, where I said it is important to understand what to do at every single stage of the data, of the life cycle of the application. At edge, we do detection, for example, at gateway or at intermediate stages, you do some fusions, and till the end, you can be in the cloud or central point in the shop itself, where you have you can have shopping mall level analytics. And maybe if it's a shopping chain, then you have you go another level at a cloud, where you combine knowledge from different shops into some kind of business level decisions and so on.
Thank you, Sofiane, and thank you to Jamal also for this answer. If anyone wants to add anything else, I can jump to the next one. So there's a lot of interesting. Il y a beaucoup de très bonnes questions. Je vais essayer de passer à travers le plus de questions possible. Et Inch'Allah, nos panélistes vont vous répondre. J'ai une question là. Voilà, ça c'est une question plutôt technique de Farouk. Can you say hello and thank you for this big initiative? My question is what do you think about transfer learning as a technique to build models? I want to make a project about face recognition, and I think it might be useful for me. So si un de nos panélistes voudrait répondre à la question ou se jeter où? Sinon je désigne quelqu'un au hasard. Ah, voilà.
Oh, non, mais je pense que je peux prendre ça parce que notre collègue là, il parle de la reconnaissance faciale. Donc, je travaille dans la reconnaissance faciale depuis presque deux décennies là, depuis 20 ans. Donc, oui, on peut utiliser le transfer learning en fait. Donc, pas que dans la reconnaissance faciale, mais dans n'importe quel domaine en fait, surtout quand on n'a pas beaucoup de données, donc on fait un apprentissage sur un domaine bien spécifique et on prend les paramètres et on va les utiliser dans un autre domaine. Donc ça, c'est déjà utilisé dans le domaine de la reconnaissance faciale, c'est déjà utilisé dans le domaine médical et c'est très intéressant en fait. Donc ça, c'est généralement utilisé dans des domaines où on n'a pas beaucoup d'informations, où on n'a pas beaucoup de données. Donc on copie les informations, le knowledge, le savoir qu'on a sur un autre domaine en fait semblable. Et c'est très utilisé et à la mode en fait.
Merci beaucoup, Dr Hadid. Est-ce que j'ai entendu quelqu'un peut-être qui voudrait ajouter quelque chose? Sinon, on passe à la prochaine. Parfait.
Juste peut-être une clarification. Transfer learning is a method for training. It's not for building architectures, right? Aziz, Abdenour?
Yeah.
C'est pas. Oui, transfer learning, c'est pas pour construire une architecture, c'est pour transférer les paramètres dans un modèle vers un autre en fait. Donc on suppose déjà qu'on a notre modèle, donc c'est l'apprentissage en fait. Donc on fait un meilleur apprentissage avec le transfer learning.
Parfait. Merci beaucoup pour votre question, pour votre réponse et merci à Farouk.
Maybe there's one just one detail. What is extremely important and what Hadid has said, which can be a kind of a take-home message, is the data. Transfer learning helps when you don't have enough data in your specific domain. So you are going to use an adjacent domain where you have enough data. You train your model there, and you transfer. So you are compensating for the lack of your data in your specific domain. That's where it is important.
Sounds good. Perfect. Merci, Sofiane. Donc, merci pour vos réponses. Je vais donner la main à Yasmine qui va présenter la prochaine question.
Oui, donc j'ai une question plus technique. Je vais la montrer ici. Donc, Théo dit are machine learning scientists rewriting existing statistics and applied the mathematics theory? For example, covariant become features, nonlinear regression become neural network, sample transformation of random variable become normalizing flow, placing a Gaussian pair of parameters become L2 regression, so on.
Want to take it? I think, yeah. Aziz, you want to?
Yeah, let me just give a comment. I think this is kind of two schools of thoughts and things like that. So, well, machine learning scientists are not trying to rebrand anything. I believe it just happens that there is a big intersection between what machine learning is doing and what statistics used to be, and we are using a lot of statistics and mathematics in this work. So there is no competition, or no how can I say, there is no competition between the two schools, but it just happens that there are a lot of similarities, and yes, maybe in a certain field you see a name that is given to a certain discipline which is given a different name in another discipline. Yes, that's possible, but I don't think this is kind of a big issue, as long as we are making useful progress. And personally, I don't see why do we have to be so, how can I say, so strict about the terminologies and so on and so forth. As long as we are doing something useful for society, then I believe it's fine. Whatever the name is, whatever the name, the how can I say, whatever the field that comes from it, it doesn't matter, as long as we are making something useful to society. That's my personal opinion. If someone,
so I would add something here. I think machine learning is not a new field. Yeah. The first perception was designed in '58. So and if you go to and there's nothing wrong in using the basic science enablers to build that. To a process, and if you see, for example, the training is back projection is something that was developed in the machine learning world, and the training is optimization. It's using a lot of regressions, a lot of cost function definition, optimizations, and so on. So there's no rebranding, absolutely nothing, no such.
Yeah, and if I can add something also, and this is not a problem that is. I mean, we don't see this only in machine learning and statistics. Si tu prends les mathématiques et la physique aussi, il y a beaucoup de termes en physique qui ont un différent nom en maths. Donc, c'est comme dans tous les domaines, c'est pas nouveau pour machine learning ou bien statistics. Mais ce qui est important en fait pour les étudiants et aussi les chercheurs, c'est de comprendre les concepts qui sont derrière les mots. Ne pas s'intéresser uniquement aux mots, mais c'est surtout de comprendre les concepts qui sont derrière. Et surtout faire des liens entre les différentes disciplines. Par exemple, l'innovation, des fois, on la retrouve ailleurs, pas forcément dans le domaine qu'on étudie. Voilà.
Ok, parfait pour votre réponse. J'ai une autre question ici de Samir Abbas. Il dit, does the cloud efficient in interpreting quantum computer output? Donc, qui veut répondre à cette question?
Je ne sais pas s'il y a quelqu'un qui est un expert dans quantum computing. C'est un domaine qui est très nouveau en fait. Donc, voilà, on doit étudier un peu plus.
Ouais.
C'est vrai, on a reçu beaucoup de questions sur le
Oui,
quantum
effectivement, c'est un domaine très émergent, mais bon.
C'est vrai.
But I think interpretation. I mean, that's. I don't think there will be an answer for this. Why cloud? I mean, quantum. We are talking about computer. I mean, is that the complexity and I don't.
I think he's asking about interpreting some outputs. In my opinion, if we can get a lot of data, I think that with artificial intelligence we can interpret. We can try to explain a lot of things if we can get a lot of data. So this is my just explanation. I am not very familiar with quantum computers, but at least I know that if you give me a lot of data about the outputs, I can, with artificial intelligence, it can help me to interpret, to explain why we get these outputs.
Thank you, Abdenour. Si tu veux, Yasmine, je peux continuer avec les questions qui nous restent. On essaie de couvrir le maximum de questions. On est désolé si on a passé certaines de vos questions, mais on va essayer de passer encore quelques questions avant de terminer le live. Donc, je vais aller passer directement aux commentaires qui sont ici. Ça, c'est une question qui est intéressante quand même. Donc, Rachid Zarita, who do you think will successfully monetize edge computing? Donc, on a déjà des experts dans plusieurs industries académiques. On a aussi quelqu'un qui travaille dans l'industrie à 100%. Donc, si quelqu'un voudrait, si les deux côtés voudraient bien proposer une réponse à cette question à Monsieur Rachid.
I think this is, I can just share my thought. I'm sure that everyone will have a thought. I will start. I think Algeria, what we have good in Algeria is the opportunity. Is that, we have a lot to do, okay? So I think a lot can be monetized in Algeria. I think a lot of applications that we have been presenting today, they can be localized, as we said. And, if you are the first, this is opportunity in the market, then you have a more opportunity to do it. And I think the opportunity will not last forever because we are living in a world. At some point of time, we have to open, and we will be in bombarded by the big guys who are monetizing this everywhere. So
perfect.
There's a lot of opportunities there in Algeria.
Perfect. Thank you for your answer, Sofiane. Does anyone wants to comment on that or add something?
I can say something. So if I want to be strict, to give a strict answer to this question, so the person who will successfully monetize on edge computing is the person with the best business model. So that's the answer. In short, but
elaborate answer as the question.
I can elaborate it more. So what happens with business is that you need to go through several cycles. You don't know actually what's going to be successful. It depends on so many parameters that you cannot control everything. So what we can do is we can try, and then we have a certain idea of who is gonna be asking for this product or so on, and then we try in small and short steps to see the reaction of the market to our ideas. And then if one idea picks up and is interesting, then we can invest even more. So that's basically how it is. That's how it has always happened in Silicon Valley and everywhere else. So there is no single answer or no. How can I say? There is no correct answer for this. Actually. That's
so I just want to add one thing here, which is important, I think, related to Aziz's question, but it is also related to our initiative here, because one of the differentiators for the proposal is business value. So the business value has to be defined. So I think you can have the same edge AI application. Somebody who has a good business model can make it success, and somebody else will not get anything out of it. So that's why I think what Aziz is saying is extremely important, and that's also important in the way the proposal will be shaped for this proposal, so that it can be successful. can be selected at the end.
Perfect. Thank you so much, Sofiane. Merci beaucoup pour ta réponse. Donc voilà, donc je vais donner maintenant la main à Oussama pour malheureusement ce qui sera possiblement la dernière question. Donc Oussama.
نعم الحسين. السؤال الأخير هو السلام عليكم. السلام. أهم سؤال يطرحه الطالب كيف أبدأ ومن أين أبدأ؟ So where to start and how?
From Algeria AI Challenge.
That's it.
And the how, we will tell you the how. We have all the guys here to tell you the how. So.
That's a very good answer. Parfait, شكرا. Oussama, si quelqu'un veut ajouter autre chose et peut-être complémenter à la réponse de Sofiane.
Ouais, peut-être. Actuellement, ce qui est bien, c'est qu'il y a beaucoup de tutorials online. Donc, si quelqu'un, par exemple, s'intéresse veut commencer, veut pénétrer ce domaine, il faut trouver un tutoriel online. Et généralement, il y a des tutoriels qui expliquent le machine learning, deep learning, vraiment étape par étape, avec des exemples de code. Ça peut être vraiment un bon point de départ, en fait.
Oui, je suis tout à fait d'accord avec toi, Hamid. De nos jours, il y a beaucoup sur le GitHub, il y a beaucoup de open source. Il y a des données, il y a des algorithmes, il y a tout. C'est bien expliqué et c'est public là. Donc déjà, quelqu'un peut commencer avec ça. Et si quelqu'un est intéressé, il ne faut pas hésiter à nous contacter. On est là pour aider, pour travailler ensemble en fait.
Yeah.
Parfait. Merci beaucoup, Abdenour. Alors, je vais me donner la main. Voilà. Merci beaucoup aussi Oussama d'avoir posé la question. Donc malheureusement, c'est tout le temps qu'on a pour répondre à toutes les questions. Pour ceux qui ont posé des questions sur le Facebook, on va essayer d'aller répondre à vos questions. We'll try to answer to all your questions directly from the post. Que ce soit nous, que ce soit un des experts qui est présent ici, on va faire le travail nécessaire pour répondre à vos questions. Malheureusement, on a peu de temps qui nous reste, mais on vous remercie énormément pour toutes les questions que vous avez posées. Je voudrais aussi prendre le temps pour remercier Hamid, Abdenour, Abdelaziz et Sofiane d'avoir fait cette excellente présentation, et aussi Oussama et Yasmine d'avoir aidé à organiser.
Can I add something?
Yes, of course. Any last words?
Yeah, so basically I was trying to do something. I was trying to invite Mouloud Koudir, who is one of the scientific the advisory board member, and he is the director of Lini وين احنا في ربعة خرجها. Donc ça c'était pas possible, mais j'aimerais bien passer un message pour lui. حبيت vraiment le remercier. Il était un de nos professeurs préférés. Il a contribué à nos parcours. Je voulais vraiment le remercier. J'espère qu'il va l'entendre. Merci.
Merci beaucoup, Sofiane. Je vais peut-être passer, si ça vous dérange pas, Monsieur Hamid, pour peut-être un mot de la fin sur la présentation que vous avez faite et sur le sujet.
Ok, donc la pression, une grande pression. Okay. Donc, je tiens surtout à remercier les organisateurs, initiateurs de cette initiative. Je pense que c'est... pour moi, ça fait en fait longtemps que j'essaie je cherchais à collaborer avec des collègues en Algérie, essayer de contribuer en fait plutôt to pay back what I got from my teachers and so on. Et là, je pense, une opportunité pour nous de rendre to pay back a little bit. Et mon message peut-être pour les étudiants. Donc, si vous avez des questions, ou bien vous voulez de l'aide, ou bien des orientations dans ce domaine, il ne faut pas hésiter à nous contacter. Et merci.
Parfait. Merci beaucoup, Hamid. Je vais passer à Abdelaziz, peut-être un petit mot de la fin.
Ok. En fait, je suis vraiment très content d'avoir pu participer à cet événement. Ça fait plaisir qu'on peut, qu'on peut expliquer un petit peu nos expériences. Et je serais vraiment très content si quelqu'un a pu apprendre quelque chose. J'espère qu'il y a beaucoup de gens qui ont pu apprendre beaucoup de choses à partir de ce webinaire. Et puis, bonne chance pour tout le monde qui veut faire quelque chose de bien avec edge computing ou bien AI et autre chose. Et on est là pour orienter ou bien participer ou collaborer et tout, etc. Merci.
Merci beaucoup, Abdelaziz. Passez au suivant. Abdenour, last but not least, un petit mot. Je pense que vous êtes muté. Voilà.
Ouais, merci beaucoup. Donc, ça m'a fait vraiment plaisir de discuter avec vous, de partager ces moments-là. Donc, je remercie tous les organisateurs, en fait. Et je reste toujours disponible. Donc, s'il y a des gens qui ont des questions, bien s'il y a des gens qui veulent continuer la discussion, ça fera toujours plaisir, en fait. Donc, je suis toujours disponible.
Merci beaucoup. Parfait. Merci beaucoup, Abdenour. Je vais juste rajouter un petit mot pour nous rappeler à tous ceux qui nous regardent que tout ça, c'est un objectif. On veut vraiment que les gens s'inscrivent au plus possible à cet événement, à ce concours. On a des experts extraordinaires pour aider les gens à développer leur projet. Donc, n'hésitez pas à appliquer, à envoyer la forme qu'on a présentée sur le site, que je vais d'ailleurs mettre ici, voilà, au maximum. Et on est très heureux de recevoir vos applications.
La dernière chose, oui. C'est juste, j'ai reçu un rappel. Juste pour féliciter encore nos étudiants qui ont eu leur bac. C'est un début. Inch'Allah, il a plus de succès, Inch'Allah. Et merci à vous tous.
Merci beaucoup. Merci pour le rappel, Sofiane. Merci beaucoup à tout le monde. Donc, si jamais personne n'a rien à ajouter, je pense que ça va clore aujourd'hui le webinar. I would like to thank everyone that was involved in this webinar, from Japan to Australia, from Montreal, Zaire. I think, mashallah, we've combined multiple continents. Merci beaucoup à tout le monde. Et Inch'Allah, prochain webinar qui sera disponible, on va le mettre sur notre page. Et n'hésitez pas à appliquer. Et je vous souhaite une très bonne soirée. Salam alaikum.
Merci.
Merci tout le monde. Salam alaikum.